So one question that you may well have is, how do we know if a distribution is normal or not? We're typically working with a sample, and in order for us to use the normal probability distribution and compute probabilities in that way, we have to be assured that the population actually is normally distributed. How can we possibly know that if we're not dealing with the entire population? Well, on page 237 in your book, we've got a list of 4 different ways, and there are a handful of others, but these are 4 major ways, and the only ones you'll need to worry about, that we can determine if a particular sample comes from a population that is approximately normally distributed. Won't necessarily have to fit exactly. As long as it's approximate, that's going to be good enough. And the first way that we can tell that, item number 1 in the tan box there on page 237, says we can construct either a histogram or a stem and leaf display for the data and just look at the shape. See if it pretty closely follows the normal curve. Let's see how we can do that. I've got a data set here open. It's actually the EPA gas data set from chapter 4. And you remember how we create a histogram. We go over here to graph and choose histogram. And we'll select the miles per gallon column here. I'm going to do one more thing before I click compute, and that is to scroll down here to display options and tell it to overlay the normal distribution. So not only is it going to create the histogram, but it's also going to show us that bell curve and how well they fit together. We're not going to have to guess whether it pretty well fits the curve or not. It's going to be displayed there for us. So then we click compute or hit enter, and that a little bigger. And you can see that it's definitely not an exact fit, but the shape of those columns for our histogram does fairly well follow the shape of that bell curve. That's all we have to do, create a histogram there. And so that's test number 1, and it looks like we've pretty well got this bell-shaped distribution with this particular data set. Test number 2 is to compute our intervals, our mean plus or minus 1 standard deviation, our mean plus or minus 2 standard deviations, and our mean plus or minus 3 standard deviations, and kind of evaluate those using our standards from the empirical rule. Well, at the very top of our graph here, it tells us what the mean and the standard deviation are. And just to use kind of round numbers here, our mean is roughly 37, 36.994. Our standard deviation is roughly 2.5. So if we start at 37 and go 2.5 above that, we're at 39.5. 2.5 below that, we're at 34.5. So basically what we would do is say, okay, 34.5 is going to be somewhere about in here. 39 is going to be somewhere, or 39.5 is going to be somewhere out in here. And if we eyeball that, it does look like about 2/3 of all of those values fall within that range. Going out another standard deviation on either side is going to put us at 42 on the top end, or at 32 on the bottom end. 32 is going to be about right here. 42 is going to be about right here. And again, eyeballing it, it's going to look like about 95% of those values are within that range. One more standard deviation on either side would put us at 44.5 and 29.5. Well, 29.5 is going to be out here, so there's nothing below that. 44.5 is going to be right out here, so there's just a slight amount of values out there. So again, it looks like about 99.7% of all of the values are within 3 standard deviations of the mean. So using that empirical rule estimation, looks like we are approximately normal here as well. Our third method for assessing normality is to find what's called the interquartile range, which is simply the third quartile value minus the first quartile value. Divide that by the standard deviation, and that ratio, interquartile range divided by the standard deviation, should be approximately 1.3. And by approximately 1.3 here, it doesn't have to be exact. It could be 1.2, 1.5, something that's approximate. Well, how do we find the interquartile range and the standard deviation? That goes back to finding our descriptive statistics that we talked about in Chapter 2. We'll go to Stat, Summary Stats, and we want those based on our columns here. The only column we're dealing with is MPG. And we want to go down here to our statistics, and if we scroll down, you'll see that there's an option down here to get IQR. Now we want those other values as well, so we're going to hold down the Control key while we click on IQR. And then click Compute. That's going to give us all of our descriptive statistics here. We've got the mean, the variance, the standard deviation, the interquartile range. If we take that interquartile range of 2.7, divide it by the standard deviation of 2.4, we're going to find that that does in fact come out pretty close to 1.3. 2.7 divided by 2.4 is 1.125. So again, it's not exactly 1.3, but it certainly does come out to be approximately 1.3. So just like we saw from our histogram, it's based on this sample, it's not a perfectly normal distribution, but it is lining up pretty close. Let's take a look at our fourth and final method of assessing normality here. And that is to take a look at a normal probability plot for the data. We can generate those automatically in StatCrunch. It's going to be a graph. And the type of graph that we need that equates to a normal probability plot is referred to as a QQ plot. Why they call it a QQ plot, I have no idea. It would make better sense to call it a normal probability plot, but this is what we've got, QQ plot. Go to Graph, click on QQ plot, tell it we want it for miles per gallon, and hit Compute. And what we're looking for to show that it is approximately normally distributed is if these dots essentially line up along the straight line. They absolutely do. And so if we had a straight line going in the middle and then dots all over the place, then it would not appear to be normal. But this one lines up almost exactly on that straight line. And so all four of our tests here show that we do have approximately normal data, and we can go ahead and feel free to use that normal distribution calculator, even though we don't know for sure that it's a normally distributed population.